Okay, here in this video, we're going to work on a few problems of different roots, odd and even roots. So the odd roots are the fifth roots, cubed roots, that would be odd, and we worked in that in the previous video, the seventh root, the ninth root, the fifth root. Even roots is when the index is an even number. So here we've got the fourth root we're going to be playing with. Okay, so we've got the fifth root of 32. Now remember, the more you know of your roots from the exponent quiz, so the exponent quiz has 1 squared through 25 squared. That's going to help you with your square roots. 1 cubed through 10 cubed. 1 to the fourth through 5 to the fourth, and then 1 to the fifth through 4 to the fifth. So let's look at those fifth roots right here. 1 to the fifth is 1. That means that the fifth root of 1 is 1. 2 to the fifth is 32. That means the fifth root of 32 is 2. 3 to the fifth is 243. That means the fifth root of 243 is 3. 4 to the fifth is 1024. Whoopsie, jumping ahead, 1024. And that means the fifth root of 1024 is 4. So coming back here, you might say, how do you know that so fast? Well, because I have that basis, that foundation of additional facts that I really encourage you to memorize. So the fifth root of 32 is simply 2. And that's because 2 to the fifth is 32. The fifth root of negative 32, fifth root of negative, remember what we did the last time. You can take that negative when it's odd, when odd, take the negative to the outside. So when the index is odd, you can take the negative to the outside. So I've got the negative on the outside, and now I've got the fifth root of 32. And the fifth root of 32 we just did, that's 2. So I've got negative 2. And here, we just did. Here, look at this. Negative fifth root of 32, or the opposite of the fifth root of 32. And that's what we have right there. Same exact thing, the opposite of the fifth root of 32. Well, that's going to be the opposite of 2. And then we've got a double negative. So now we're going to put it all together. This negative on the inside, I can take to the outside. And there's already a negative on the outside, so I'm going to have 2 of those. A negative times a negative times the fifth root of 32. So we took that negative to the outside. Well, 2 negatives make a positive. So I've got the positive fifth root of 32. And the fifth root of 32 is 2. Positive 2 is my answer. The seventh root of x to the seventh. The seventh root of x to the seventh, you've probably guessed it, or not guessed it, you probably learned it. The seventh root of x to the seventh is x. There's probably no guessing involved. You're probably very confident that the seventh root of x to the seventh is x. And the ninth root of t minus 1 to the ninth is simply going to be t minus 1. And then the fifth root of 4a to the fifth power, the fifth root of 4a to the fifth power is simply 4a. And that's because those undo each other. So it's an inverse operation. Now remember when when the index is even, the radicand must be greater than or equal to 0. The radicand has to be greater than or equal to 0, so it's got to be positive, or 0 works. Otherwise, it's considered not real. So I've got the 4th root of 81. Well, that's back at the exponent quiz. So if we look at the exponent quiz, look at this. 1 to the 4th, 5 to the 4th. So 1 to the 4th is 1. That means the 4th root of 1 is 1. 2 to the 4th is 16. That means the 4th root of 16 is 2. 3 to the 4th is 81. That means the 4th root of 81 is 3. 4 to the 4th is 256. That means the 4th root of 256 is 4. 5 to the 4th is 625. That means the 4th root of 625 is 5. So we're looking at the 4th root of 81. What times itself 4 times is 81? Well, that would be a 3. So you can think of it this way, the 4th root of 3 to the 4th power. Well, that's just going to be 3. Then we've got the opposite of the 4th root of 81. Well, that opposite is going to stay on the outside, and then the 4th root of 81, which we just did, is 3. That gives us a negative 3. The 4th root of negative 81. The 4th root of negative 81, and that's where this occurs now. When the index is even, the radicand cannot be negative. So the index is even, the radicand cannot be negative. Therefore, this is not real. So that answer right there is not real. And then the 4th root of 81, x to the 4th, I'm going to separate it out. The 4th root of 81 times the 4th root of x to the 4th. Well, the 4th root of 81 is the same thing as the 4th root of 3 to the 4th, which is 3, times the 4th root of x to the 4th, which is x. 3 times x is 3x. Voila. And that concludes our series of videos on square roots, cube roots, all sorts of odd and even roots of numbers.